Okay, so today's lesson is lesson 22, getting the job done, speed, work, and measurement units. Today we're going to be looking at the distance formula. So if you read at the top, it says, if something is moving at a constant rate of speed for a certain amount of time, it is possible to find out how far it went by multiplying those two values. In mathematical language, we say the distance is equal to the rate times the time. So the distance, or d, is how far we have traveled. R for rate of speed tells us how fast we are going. And t for time is how long it takes. There are two distance formulas that we can use. If we're looking to find how far we went, or the distance, we use that same formula from up in the top there. D equals RT, which just means the distance is equal to the rate times the time. Remember, when we have two variables, or a number and a variable directly next to each other, that means that they're being multiplied together. So RT means rate times the time. Another one that we can use is if we're looking to find our rate of speed, or how fast we went. And to use that, to find that, what we would do is we would take our rate of speed, or what we're looking for, and take the distance we went and divide it by the time that it took to go that far. So let's look at some examples so we can see what this looks like. Example 1 says a walker walks at a rate of 2.5 feet per second. So now something that I'm going to show you is that when we see something along this line, a distance per something, and this slash here, that means per, or for one. So this is saying that somebody's walking 2.5 feet every second. So that is their rate. It even tells us rate, but sometimes it may not say rate. You just have to kind of know that that feet per second, or that distance per time, is how fast it is, or the rate. So I'm going to put R right above that to help me remember that that number is for the rate of speed. He walks for 90 seconds before he stops to tie his shoe. Hopefully, we all know that 90 seconds is a measurement of time. So I'm going to put T for time above that. It's asking us, how far did he walk? So we're looking to find the distance that this person walked. So if you notice, to find the distance, we can use the formula D is equal to rate times time. So whenever I'm using a formula, I want to start by writing that formula out. D equals RT, or distance equals rate times the time. So my distance is what I'm looking for, so I don't know that. I'm going to replace the R with my rate of speed, which is 2.5. And then I'm going to replace the T with the time that it's taking them to go, or 90. Now, something that's also super important to remember with this is that your rate of speed and your time have to be in the same terms. So what I mean is, since this is seconds and this is seconds, we can just multiply the two numbers together. If they were different, we would have to convert the time to the same unit that's used in the rate, which we'll see a problem like that coming up. So you really do have to pay attention that your rate and your time have the same units in them. So now what we're going to do is we are going to multiply the two numbers together, and I am just going to use my calculator to do so. So in order to do this, I'm going to do 2.5 times 90, and that's going to give me the distance, or D is equal to 225. And if you look back up into the problem, since feet is how fast he's walking, that would be the unit. So 225 feet. So now there is a way to do this with equal fractions, which we've kind of been doing a lot this year. So let's look at this. This is saying 2.5 feet per second, or 2.5 feet for 1 second. Remember, we said that that's what that line means, the per, or for 1. So I can set that up equal to see how long how far he can walk in 90 seconds. To get from the 1 to the 90, I multiplied by 90. Since I multiplied my denominator by 90, I'm going to multiply my numerator by 90. 2.5 times 90 is the math we've already done in our calculator. So it's going to give us the same answer. It's just whichever one you're more comfortable using, the formula or the equal fractions. Okay, so let's look at the next example. The next example says a runner can run 50 feet. That's how far they can run, or the distance, in 8 seconds. 8 seconds is a time. What is the rate of speed? So it's telling us we're looking for a rate of speed. If you notice, this is the formula we can use to find the rate. Our rate is equal to the distance divided by the time. Our rate is equal to the 50 feet divided by the 8 seconds. Now, I'm going to suggest when you're doing a rate that you label it, so feet, seconds, because that's going to be helpful with our answer at the end. So our rate then, if I take 50 and divide it by 8, I get 6.25 as my answer. My units for this would be feet per second. Feet per second. Okay, so that's the rate of speed, or how fast that they are running. We can also do this with equal fractions. We have 50 feet for 8 seconds. Whenever we're trying to find a rate of speed, we're trying to see how fast they can go in one of whatever time we're looking at, so how fast they can go in 1 second. So we would divide 8 by 8 to get that 1, divide the 50 by 8 to come up with that 6.25 feet for 1 second. So again, it's just whichever you're comfortable with. If you prefer to use the formula, that's wonderful. If you prefer to use the equal fractions, great as well. Let's just look at a couple more examples. So example 2 says I drove my car on cruise control at 65 miles per hour. So 65 miles per hour, we see that word per. That's telling us that this is how fast they're going, or their rate of speed, for 3 hours without stopping. 3 hours is a time. And we're looking to see how far. So again, this is distance. We're looking to find how far they went. Something to note, both units in the rate and the time match, so that's good. We can just go ahead and use our distance formula. To find distance, we would use d equals rate times time. So d would be equal to 65 times 3. Put 65 times 3 into our handy-dandy calculator. And we see it's 195. And if we look back into the problem, it would be miles for the distance. Again, if you prefer, you can do 65 miles per hour, means for 1 hour. And we're trying to figure out how far they can go in 3 hours. So 1 times 3 is 3. 65 times 3, same math we did right here, gets us the 195. It's just the different setup. Again, depending on whichever one you like, you do not have to do both. You can choose the one you like. The next one is just a little bit different. So for this one, it says an inchworm can move at 20 centimeters per minute. So there's that per, that's telling me this is a rate. If an inchworm travels for 4 hours, how far will it travel? So 4 hours is our time, how far is what we're looking for, or our distance is what we're looking for. So we can use that distance equals rate times time formula. However, the big difference with this problem is that our units don't match in our rate and our time. Here we're talking about minutes, here we're talking about hours. So something that's important here is, once again, they have to match. I can't change the rate of speed at which they're going, but I can convert the time to match the unit used in that rate. So I can turn 4 hours into minutes. In order to do this, I know that 1 hour is 60 minutes. Okay, that should be something hopefully that you know. I'm trying to figure out how many minutes 4 hours is. So what I would do is I would say 1 times 4 is the 4. So 60 times 4 would give me the number of minutes that that's equal to. So that's 240 minutes. Okay, so 4 hours is the same thing as 240 minutes. So when I go to do my formula, I can use the 20 for my R, or my rate of speed, but I can't use the 4 hours. I have to use the 240 minutes so that it matches with my rate of speed. So I would be doing 240. So when I go ahead and I get my answer, I'm going to do 2 times 24, which is 48, attach the 2 zeros to get 4,800. Be careful when you go to put this in PlayPosit, it would go without the comma. Okay, and you can do the same thing with equal fractions as well. 20 centimeters for 1 minute is equal to how much for 240 minutes. Again, you would have to do that conversion to figure out the minutes to minutes. Times 240 here, times 240 here. Get the same answer, same math. You would have to do this for both methods. Okay, so now you have some practice problems you can work on. Good luck.